atmosphere. See, this is the nice compilation by Postel and Shiriava in Chemical Reviews. And what we see here is, just a minute, let me just take the pointer. Yeah. You see the range from 100 picometer to 10 centimeter. This is 9 orders of magnitude we are talking about. Okay, so this is what we have in the atmosphere. You start from this side, means you have gaseous molecules which is in the order of 100 picometer to 1 nanometer range. They can come together, form sulfate, or they may not come into aerosol phase. They may remain in gas phase only. This side you have rain, snow, droplet, hail, which is ranging from 1 mm to 10 centimeter. Our focus is aerosol, which is shown in red. And if you see, the range is from 1 nanometer to 100 micron. And they are defined in, see, here it is written coarse, fine, ultra fine, which is, most of you know that based on size you are calling them ultra fine particle, fine particle, or coarse particle. And then you also see that these names are written at different places. So for example, when we are talking about mineral dust and sea spray, they are coming in coarse mode. When we are talking about sulfate, secondary organic aerosol, soot and all, they are coming towards fine and ultra fine particles. And these green things, if you see, these are bioaerosols. Pollen and spores are in pores. Then bacteria versus viruses, proteins are at lower side. So whatever you have in the atmosphere, they are all interlinked. So there is a finite possibility that things which is here, one molecule, one gas molecules, it is forming some aerosol, growing further, acting as a CCN, making a rain droplet, converting into snow or hail, and ultimately coming down. That means same particle which is starting from here can come down in the size of this order of this size. So as I said, our focus is aerosol. And what is the typical composition of aerosol we expect? So this is the typical composition, and don't think that it everywhere it will be like that only. So what you have organic, you have black carbon, you have secondary inorganic. When I am saying secondary inorganic, I mean sulfate, nitrate, ammonium. Then you have sea salts which are coming from seawater. So whatever salts are there, that is sea salt. Mostly it is sodium chloride. And then you have dust. And it is quite obvious that it will vary in time and space depending upon where you are located at. For example, you are in Pune, I am in Ahmedabad. Ahmedabad is more towards semi-arid, so I will have more dust compared to you. If you go to Jodhpur, you will have further more dust. If you go to some forest region, you will have more of organic aerosol. So depending upon where you are, your composition will change. Then also it will change with size. So if you are collecting this size range only, you will get this kind of particles. If you are collecting this size range only, you will get these particles. And if you are collecting all together, it will be a mixture of all. And then it also changes with transport and removal mechanism. Transport means whenever things are getting transported, we know that finer particle will go farther, whereas coarse particle will fractionate during the transport. And removal mechanism, whether they are getting removed by dry deposition or wet deposition, depending upon that, it can change.